All right, so again, we're ahead. I'm only the schedule is supposed to be up to 4.3, 4.4. I'm already up to 4.5, and we even have some so-called buffer days where we can afford to fall behind, so to speak. Okay, so we're in a nice part of the schedule where I'll lecture a while, and we'll probably finish early, in which case I'll let you ask questions, and if the questions don't continue, then we'll just stop. Okay, making a change to the 4.5 assignment, which I'll start today. I want to include problem 2. The reason for that is problems 1 and 3 both involved, I think it was the cosine, and there wasn't any sine function. So include problem 2. Yes, I realize it's an even number. And cross off the last problem, which was 35. Okay, so again, change for 4.5. Skip the last problem, 35, but throw in problem 2. I actually want to give you 4 also, but that's too many evens, I guess. So we'll just go with this. All right. Okay, so I gave an introduction last time, and let me show you what's happening now. So in 4.5, page 229, we're going to be asked to graph a lot of these now. Okay. Figure out the amplitude, the period, and so on. Okay. Again, I'll show it to you again for those of you who don't plan on getting the book. Here are the problems. Again, this is on page 229. So there's some problems there. You get these off the video. And on the next page, 230. And there's some problems there. And some problems there. And some more there, if you need them off the video. Okay. All right, so basic ideas you want to use are here on page 225. I gave it to you also. Well, the version that I gave you is a little bit different. Okay, I factored out the B. That's actually what I prefer. In fact, that's what you're going to have to do anyway. Okay, so the amplitude is the absolute value of A. The period is 2 pi over B. Okay, now after factoring out the B, okay, you already know about the horizontal and vertical shifts. So I would say these two are correct. The last one is correct, but I don't really want you to look at it. Don't even look at that last one. Okay. I want you to have the equation factored. So this B here or here should be factored out. If it's factored out, then you already use your translation laws as before, where this thing will move either left or right, and the thing on the outside would move either up or down. Okay, and I'll show you what I mean when we do some of these problems. Okay, so yes, a lot of these problems have A, B, and C. So, you know, I might just do one from each type. Okay. So here we go. What I was going to show you 1C. Y equals 1/4 cosine of 4x. Okay, so the amplitude is the absolute value of this number, this coefficient. Amplitude is 1/4. Okay, if this had been a negative 1/4, we would still say the amplitude is 1/4. Okay. The period formula is 2 pi divided by the coefficient of x here. 2 pi divided by 4, which is pi over 2. So this finishes one complete period by the time we reach pi over 2. Right. Now, we know cosine starts off at the maximum. Okay, I gave you that little chart last time where cosine goes maximum, 0, minimum, 0, maximum. Okay, ordinarily the maximum would be at 1, but because I'm multiplying by 1/4, I only go as high as 1/4 and only go as low as negative 1/4. So that's supposed to be 1/4, that's negative 1/4. Okay, and furthermore, I finish an entire period not after 2 pi, but after pi over 2. Okay, so from here to here is one complete period. Okay, all I want to do after that is break this into 4 pieces. Okay, so how do I do that? Well, you cut this in half, and you cut each of these in half. Okay, so I say to myself, what's half of pi over 2? 1/2 times pi over 2 is pi over 4. Okay, so that's halfway. Cut that in half. So what's half of pi over 4? It's pi over 8. multiply this by 1 over 2, right? You have 2 times 4 is 8 in the denominator. Okay, so again, if you want to multiply by a half, you multiply the denominator by 2, that's pi over 4. Okay, then you want half of that, just multiply the denominator by 2, that gives you pi over 8. Okay, and now to label all the others, it's pi over 8, 2 pi over 8, 3 pi over 8, 4 pi over 8. So I know this is 3 pi over 8. Okay, you should be able to come up with these numbers for me. Okay, beginning, ending, halfway, 1/4, and 3/4 marks. Those are key points for sine and cosine graphs. So you should be able to tell me what those numbers are. Okay, and instead of going up to 1 and -1, it's only going to go up to 1/4 and -1/4. So here we go. Maximum, 0, minimum, 0, maximum. So that's a graph of 1/4 cosine 4x. Okay, so it still has the same cosine shape. Okay, same basic shape as this. Okay, it's going to be maximum, 0, minimum, 0, maximum for cosine. But cosine normally starts at 1, goes down to -1. Because I have a 1/4 in front, it's only going to go as high as 1/4 and as low as -1/4. Okay, and again, the regular cosine function takes 2 pi to finish an entire period. But this one is 2 pi divided by the b. 2 pi divided by 4 is pi over 2. So it finishes one period only up until pi over 2. If you want to think by comparison, here's pi over 2, right? For the graph in problem 1c, it finishes that whole up and down sequence by the time I reach pi over 2. So it's almost like you take this graph here and scrunch it in. Think of that spring and you just kind of jam it in, sort of. All right, so that's what we got over here. Okay, let's try 2c. Okay, y equals -2 sine of 3x. Okay, it's a sine type function. The amplitude is the absolute value of -2, which is 2. Okay, the negative means it goes opposite of what the regular sine function does. So if you look at sine, sine goes 0, max, 0, min, 0. If you want to put this in your cheat sheet, you may. But because of the negative makes it start down first and then up. So it would start at 0 and it'll go to the minimum 0, maximum 0. So this graph is going to start down instead. Okay, now what about the period? The period is 2 pi over 3 because the coefficient here is a 3. That's a 3 there. Looks like that. So the period is 2 pi over 3. So it finishes an entire period by 2 pi over 3, not 2 pi. Whoops, 2 pi. Now where's 2 pi over 3? Well, this is 2 pi, right? So just divide it by 3. It's almost like I scrunch it in by a factor of 3. So kind of jam this shape. Imagine that it's a spring and just kind of jam it in. So it finishes that entire up and down stuff by somewhere over here, let's say. Okay. Now again, how do I label all the rest? So I already put it there, but suppose you don't know it. Okay, it finishes after 2 pi over 3. So I want to know all these in between marks: halfway, the 1/4 mark, and the 3/4 mark. Okay, so first I go halfway. That's easy. So what's half of 2 pi over 3? 1 pi over 3. So pi over 3. That's in the middle there. That's the halfway mark. Now I want the quarter mark. 1/4 mark means I take half of pi over 3. That's pi over 6. Okay, so how do I find this one now? I would start counting by pi over 6's. Pi over 6, 2 pi over 6, right? Which reduces to pi over 3. 3 pi over 6. 3 pi over 6. There it is, pi over 2. And 4 pi over 6, which reduces to 2 pi over 3. Okay, so one more time. I know the period is 2 pi over 3. How do I get the halfway mark, 1/4 mark, 3/4 mark? Okay, so first find halfway. So what's half of 2 pi over 3? You know, if you stop and think about it, what's half of 2 times anything? Well, one of those, right? It's like saying what's half of 2 apples? 1 apple. What's half of 2 million? 1 million. What's half of 2 pi over 3? 1 pi over 3, or just pi over 3. Then I take half of that. So 1/2 times pi over 3. 2 times 3 is 6 in the denominator, so pi over 6. Then how do I find the 3/4 mark? Just count by pi over 6's. Pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6. And notice each of these reduce to what they're supposed to be, right? Count with me, pi over 6, 2 pi over 6, which reduces to that. 3 pi over 6, which reduces to that. 4 pi over 6, which reduces to 2 pi over 3. So there we go. And from what we said, because of the negative, okay, now regular sine function goes 0, maximum, 0, minimum, 0. But because of the negative, it starts down. So 0, minimum, which is -2, because of the amplitude, 0, maximum, and then back to 0. Okay. All right, so that's it for that one. Okay, now a little bit tougher. Show you number 11. So now for some of these problems, we have translations also, right? We're moving left or right or up or down. We've done stuff like that before. Okay, so I'll show you a couple of those. I'll show you number 11. Y equals 1 plus cosine parentheses 2x plus pi. And I'm going to show you the way that I want you to do it. Okay, so if they give it to me like that, factor out the 2 parentheses. Okay, so write it like this. So if I'm going to take out a 2, I would divide each of these by 2. So if I divide by 2, that's 1. Divide that by 2, it's pi over 2. So do you agree with me? That is the same as that. If you distribute 2 times x, 2x, 2 times pi over 2, the 2's will cancel out. So I do have pi. And I'll put the plus 1. Okay, now you know the translation rules just like before. Okay, so from before, x plus pi over 2, that is a shift of pi over 2 to the left. And what's plus 1? That takes the whole graph and shoves it up 1 unit. All right, so let's take the base function. Let me just talk about not having that or that yet. Okay, just cosine 2x. Okay, once I graph cosine 2x, I know what to do. Then I move pi over 2 to the left and 1 up. Okay, cosine 2x, what's the amplitude? 1. The coefficient is 1. The period is 2 pi divided by the b, the coefficient of x here. 2 pi divided by 2 is pi. All right, so it finishes 1 complete period after pi. Not 2 pi, the regular cosine finishes 1 period by 2 pi, but it finishes that entire, down and up sequence by the time it reaches pi. So again, it's like you take this picture and jam it in so that it finishes everything by the time it reaches pi. So there we go. Cosine goes maximum, which is 1, 0, minimum, 0, maximum. Okay. So we know it's going from 0 to pi. Pretend I cover this up. It's too late. You've already seen it, but anyway. And pi. How do I get the in-between numbers? What's half of pi? Pi over 2. What's half of pi over 2? Multiply 1/2, right? Pretend it's 1/2 times pi over 2. 2 times 2 is 4. So it's pi over 4. Now I count pi over 4, 2 pi over 4, right? 2 pi over 4 is pi over 2. 3 pi over 4, 4 pi over 4. It works. Okay, the cosine pattern is maximum, 0, minimum, 0, maximum. Maximum, 0, minimum, 0, maximum. Okay, so there we go. Maximum is indeed 1. The amplitude is 1. So maximum, 0, minimum, 0, maximum. Okay, so 1/4 of the mark, halfway mark, 3/4 mark, ending. Okay, so beginning, ending, quarter, 3/4, halfway. Now, take this graph, and let's see, what do I do? Move it pi over 2 to the left and 1 up. Okay, so this might get a little clumsy. Move pi over 2 to the left. So 0 goes to negative pi over 2. I still count by pi over 4s. If I move this to the left pi over 2, that lands me right over there. So I finish at pi over 2. And I go mark, 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 mark here. These are still counting by pi over 4s. Okay, and maybe an easy way to think of it is pi over 2. If I move that to the left pi over 2, I'm at 0. Okay. And then what's halfway here? Negative pi over 4. What's halfway here? Positive pi over 4. And then the whole graph gets shifted up 1. So the way to think of it is, well, the maximum used to be 2, right? If I add 1, now the maximum is going to be 1. The maximum used to be 1. Now it's going to be 2. 1, 2. The minimum used to be negative 1. The plus 1 means it's now going to be 0. Okay. So my highest point is negative pi over 2, comma 2. Okay. So I take that point, move it to the left, pi over 2, and up 1. There it is. And I have the same basic shape. Okay. Now this is your sometimes called the midline. M-I-D-L-I-N-E, midline. That's where I used to say 0. But it's no longer 0, either here or here. Okay. Because I shifted everything 1 unit up, that midline is now 1. So it's maximum 1, minimum 1, maximum. So what happened to the 0? It's supposed to be 0, right? But because of the plus 1, the function had a plus 1. Where'd it go? Lost my place. Had a plus 1, right? So because of that plus 1, I no longer say 0, I have to say 1. So maximum 1, 0, the minimum 1, and then back to the maximum. Okay. So that's how that one goes. Okay, show you 15, which is much more clumsy, unfortunately. Y equals negative 2 sine of x minus 1 plus 3. Okay. Let's just talk about it a little bit. Okay, what's the amplitude? It's 2. Okay. The minus means instead of the sign starting up, it would start down. So it's the reverse of that. Okay, this shifts 1 unit to the right and 3 up. Okay. Unfortunately, that's going to be quite clumsy. Okay. And I notice there's no coefficient in front of the x. Like there's no 2 there or 3 or anything like that. So that means the period is still going to be 2 pi. All right. So here we go. So let me just start off with negative 2 sine x. Okay, so the basic sine function goes 0, maximum 0, minimum 0. Beginning 1/4 mark, halfway mark, 3/4 mark, end. Okay, so it starts up, maximum 0, minimum 0. But because this one had a negative, it was negative something, right? It's going to go 0, minimum 0, maximum 0. So the final graph is going to go down. So I'll start off with negative 2 sine x, because once I have that, I know what's going to happen there. I just shift 1 right and 3 up. Amplitude is 2, so it goes from negative 2 to positive 2. The period is still 2 pi, right? There's no number in front, or you can say the coefficient is 1, so the period is still 2 pi. All right, so here we go. 0, minimum, which is now negative 2, 0, maximum, which is 2, 0. Okay. Now, what's going to happen here? Here's one way you can analyze the range. Okay, so what am I writing here? The normal range for the sine or cosine is from -1 to 1. Okay. Now, because the amplitude is 2, I multiply that by 2. So now the range is from -2 to 2, right? Notice what's the range of this sine function? It goes from -2 to 2. And by the way, again, this is only one period. Remember, it keeps going. It keeps going like that. It keeps going like that. It goes on infinitely, the same pattern, right? All right, so I'm supposed to go from -2 to 2, but because of that +3, okay, so my minimum used to be -2. Because of the +3, what's the new minimum? -2 plus 3, which is 1. And likewise, what's the new maximum? It used to be 2, but because of that, the new maximum is going to be 5. So my range is going to be from 1 to 5. Okay, so as you can see here, I go from 1 up to 5. My midline is now 3. That's the new quote-unquote 0. Okay, so whereas before, I would say 0. In this case, it's a minimum because of negative. 0, maximum 0. In this case, I got to say 3, minimum 3, maximum 3, because the function has a +3 here. Okay. Unfortunately, there's no real nice way to add 1 to all of these. Like, how do I add 1 and add 1? Very clumsy. Now, 0 plus 1 is nice, 1. All I can say for these guys is pi over 2 plus 1, pi plus 1, 3 pi over 2 plus 1, 2 pi plus 1. You can see it's very clumsy, right? I mean, it's not as easy as like 4, 5, 6, 7, right? That's very easy to add 1 to all of them. But when they give me pi over 2, see, how do you add 1? The only way to write it is pi over 2 plus 1. Pi plus 1, 3 pi over 2 plus 1, 2 pi plus 1. Very awkward, but be that as it may. Okay, so I used to start at 0, 0. Where am I now starting? Because of this translation, 1, 3, right? 1 right, 3 up. So this 0, 0 is now here. The rest, just copy and paste. Copy that and paste it over here. So I used to say 0, but now it's 3. 3, minimum 3, maximum 3. Okay. And why does it start down instead of up? I thought the sign goes up. It's because of the negative. The negative means it's going to start down instead. So down the new 0 level, which is actually 3, maximum there. Okay, so how low does this go? Down to 1. And how high does it go? It's 5. We already established that the range was from 1 to 5. Okay, so that's how to do that one. Okay, then the other one of this type that I wanted to show you was 17. Y equals absolute value of 2 cosine x. Okay, we've tackled absolute value before. So I'll just think of the graph of 2 cosine x, and then anything that is above the x-axis stays the same. Anything below reflects up above the x-axis, right? So 2 cosine x, the amplitude is 2, the period is 2 pi. Okay, so I got them both on the same graph now. Let's look at the red graph. Yes, there's actually supposed to be some red here. It's red mixed with green. Okay, but the red. Okay, so cosine. Cosine goes maximum 0, minimum 0, maximum. Okay, so that's one period of the cosine. Okay, ordinarily I would start the maximum at 1 because of the fact that there's a 2 there, means it's going to have a maximum of 2 and a minimum of -2. So if you look at the red, yes, this includes red. I don't know if you can see it very well. This is red and green. All right, here we go. Maximum 2, quarter of the way, 0. Halfway, minimum. 3/4 of the way, 0. And then finishes at the maximum. Okay. Period is 2 pi. There is no number in front of the cosine. So 2 pi, pi, pi over 2, 3 pi over 2. So the red is the original graph. All right, now what about absolute value? Absolute value means this thing can never be negative. The final graph should have nothing below the x-axis. So the way the game works is anything that was already above, this piece was already above, this piece was already above. That stays the same, okay? So I drew that in green also. So there's red there. I'm not sure if you can see the red, but there's green also. That stays the same. But anything that's below the x-axis, that red there, pretend you take the mirror image, right? What's the mirror image of this? If you pretend there's a mirror here, it comes over here. Okay? So the final answer is this W-looking thing goes like that, then up and down, and then like that. Okay. All right, I was going to show you 25. Find the equation of a sine wave. If it says sine wave, sine curve, same thing, you know, one of these things. Shift the graph to the right 2 units, down 1, vertically compress by a factor of 2 when compared to y equals sine of x. Okay. Right 2, down 1, we know what that means. Vertical compression by 2. Okay, that means it shrinks. Okay, so you jam it vertically. That means the coefficient in front of the function is a half. Okay, vertical compression. Now you take this graph and just kind of scrunch it in a vertical. So that means the coefficient is half. It didn't say anything about the period, so I don't have to put anything there. Okay. And then we know what right 2 means. Instead of x, it's going to be parentheses x minus 2. And we know what down 1 means, minus 1 like that. So there we go. Y equals 1/2, that should be a 1/2 there. 1/2 sine of x minus 2 minus 1. Okay, and then much harder, unfortunately, 19 and 21. Find a cosine function and a sine function whose graph matches the given curve. Okay, so 19 and 21. And I'll just tell you ahead of time, it's only Tuesday, but for this week's quiz on Friday, I'm very much leaning toward giving you something like this. Okay, I give you the graph, you come up with the function. Okay, so how do I do that? Right? So, all right, so they give me this, goes like this, come up with a cosine function and a sine function whose graph matches the given curve. Okay, so what do I do? So let's look at 19. First, you're going to start off with the amplitude. What's the maximum value? Looks like it's 3. And the minimum is negative 3. Okay, so that tells me the amplitude is 3. Amplitude is 3. Okay. Next, I figure out the period. Okay, this is one period. So how far is it from here to here? Well, it looks like these are pi over 4s, right? And that's 0, right? So I'll count by pi over 4s. So negative pi over 4, 0, pi over 4, 2 pi over 4, 3 pi over 4. Okay, so this is 3 pi over 4. This is negative pi over 4. So how far is it between the two? So negative pi over 4 to 3 pi over 4, I subtract, right? So bigger minus smaller, 3 pi over 4 minus a negative pi over 4. So like that. That's a double negative, that's a positive. So it's 4 pi over 4, which is pi. So the period is pi. And now I do this. Period is pi The formula is, I don't know if you can see it, it's 2 pi over b. The formula for the period is 2 pi over b, and that's equal to pi. Okay, the easy way to solve this is you're allowed to just switch these two. I think I mentioned this to you before, but if not, whenever you have an equation like this, a fraction equals something here, you can just switch these two. That means just go 2 pi over pi equals b, and that, of course, is 2. So the b is going to be 2. Right? So one more time, I figured out the period. How far is it from beginning to end? It's going from negative pi over 4 to 3 pi over 4. So I subtract bigger minus smaller, right? 3 pi over 4 minus a negative pi over 4. That's 3 pi over 4 plus pi over 4, 4 pi over 4, or pi. I set that equal to the formula 2 pi over b. Switch these two around. B is 2. All right, so amplitude is 3, b is 2. Okay. Now, if I want a cosine function, cosine already starts at the maximum, right? So this is good to go. So y equals 3 cosine of 2x. That's a cosine function. It asks for a cosine and a sine. So you could actually write this as a cosine or as a sine. Okay, find a cosine function. Well, if I ignore this part over here and only look at this, it's already starting at the maximum, so to speak. So y equals 3 cosine 2x. Now, what about the sine? It's the same amplitude. There's going to be a 3. But the sine normally starts off at a 0, right? The sine function goes 0, maximum, 0, minimum, 0. So look at the graph. It's starting off over here. So that got shifted to the left, pi over 4. Right? Same amplitude, same period. So a shift of pi over 4 to the left means y equals 3 sine 2 parentheses x plus pi over 4, like that. Okay, so that's the answer for 19. Y equals 3 cosine 2x, to write it as a cosine function. And then y equals 3 sine of 2 parentheses x plus pi over 4 if you want a sine function. Okay. Again, why did pi over 4 shift? Sine normally starts here, but it's supposed to be at the origin, so that got shifted by pi over 4. How come I didn't have to do any shift for the cosine? Well, if I take a look at this and I ignore this part, I've already got it starting at the maximum, so I don't need to do any shift for the cosine function. Okay. All right, folks, that's pretty much it. I have number 21, but I can save that for tomorrow. I'll let you try to work at that on your own. But I'm essentially done. So if you want to ask any questions in just a moment after I finish blabbing a little longer, then you can. But for 21, it's a little bit tougher. It goes like that. So here are some hints for 21. It looks like it goes from 2 to 12. Okay, 2 to 12, which means what's the period? If I go from 2 to 12, period is 10, right? And the amplitude's a little bit tricky. Oh, you can tell what the vertical shift is right away. The vertical shift, the new midline is 1. So there's a shift of 1. The maximum is 3. So that tells me the amplitude is 2. And it goes down to negative 1, as you can see, right? So those are some hints for that one. Okay, but I was going to save that for tomorrow. Otherwise, I'm pretty close to being done with even 4.5. Okay, so it looks like for 4.5, I was almost done, except I'll do one more, and then I'm ready to start 4.6, unless you have questions about anything. Okay, and I was only supposed to finish 4.5 this week. So again, I'm way ahead. I'm supposed to finish 4.5. I'll be finished with 4.5 tomorrow. So we're going to be good for that. Okay, and again, for the quiz, I'm very much leaning toward for Friday's quiz, which is still a long ways away. I will give you a graph, something like this, and I'll say, what is the cosine or sine function? So you have to analyze what's the amplitude, what's the period, and so on, stuff like that. Okay. All right, so I'm done. Let me stop the share and check the chat. And I don't see anything in the chat. And yes, I do see some of you that logged on a little bit later. Just go ahead and send me an email. That's perfectly fine. Just the usual. Okay, so any questions? You can either unmute yourselves or put it in the chat. And if not, then we're done for the day. Okay, and that'll probably be the same way Wednesday, Thursday, and Friday, unless something goes wrong. You know, I got sick or my internet crashes and all that bad stuff. Okay. So any other questions? Otherwise, we're done, folks. Okay, I don't hear anything, so we're done for today, folks. So bye, everybody. Have a good day, and we'll see you next time. Okay, bye, everyone.
Thank you.
Thank you.